Hi everyone, today I'm going to be showing you how to find the volume of pyramids and cones. This is my first video on my channel, so welcome to Some by Miss Venegas. Okay, so it asks, what is a pyramid? Okay, so if you've never heard what a pyramid is before, a pyramid is a 3D shape with a polygon base that narrows smoothly to meet at a point called the vertex. Sorry for the typo. So let's break this definition down. So 3D shape basically just means it's three-dimensional, and a polygon base means that the base of your shape, the thing at the bottom, it's kind of holding the shape together, is going to be a polygon. So a polygon is basically just any shape that has at least three sides to it. So triangles are polygons, squares are polygons, rectangles are polygons, pentagons, hexagons, and so on that narrows smoothly to meet at a point called the vertex. So the vertex is just like the tippy top point. Um, so let me draw like a picture here. So if we want to have a pyramid and our base, let's just in this case we're just going to imagine it as a square. Okay. Okay. So that's an example of a pyramid. It's drawn really badly, excuse me. But this is still a pyramid technically, and it has a square base. Okay, so some examples that you might see in real life is this tent, because again, you see that there is like this rectangular slash, ooh, that's not a good color. There's like this rectangular slash square base, and then it meets at this vertex at the tippy top point. So therefore, it's going to be a pyramid here. Okay, similar thing. These are kind of real life examples. This helps me learn math. This is an example of a historical monument in Mexico. It's called Chichen Itza. It is a Mayan pyramid built a really long time ago, and it's 24 meters, which is 78 feet tall. It's super big, but it has a rectangular, so you can't really see in the picture, but it actually does have a rectangular base, and it does meet at the top. So even though like the vertex is kind of like another square, it kind of looks like a rectangular prism. Um, this is also a pyramid, and it's really cool because pyramids exist like in ancient civilizations. And then another cool pyramid that exists is a temple of the Great Jaguar. This is located in Guatemala, and this is also another example of Mayan pyramids. I'm not sure if this is a square or triangular based pyramid, but it is still a pyramid because again, we see that it meets at the vertex at the top here. Okay, so we want to we need to know the formula of our pyramids. So for pyramids and cones, which we'll see later on, we can use this formula called volume equals 1/3 base times height. And then for pyramids, our um, formula for pyramids that have a square and rectangular base are going to be okay, so it's going to be 1/3 length times width times height. Okay, so as long as you know, I'd say the volume equals 1/3 base times height, you should be able to derive what kind of formula you should use for any pyramid with any size base. But again, we'll go with an example. All right, let's start with an example now. So this is an example of a pyramid and it asks us to find the volume. So we're going to use the formula that we just learned right now. So remember that volume equals 1/3 base times height for any pyramid with any base. Now we're going to determine what formula do we use for this pyramid. Well, what shape is our base? So the base is the blue shaded region that I just highlighted right now. Okay, so the length and the width are both the same. They're both 7. So our shape is going to be a square. Okay, so we're going to use the formula volume equals 1/3 length times width times height. Again, this formula comes from this slide, right? The one that I just showed you guys. Okay. So now we're going to be plugging everything that we just found, into our equation. So one thing that really helps me doing, when I'm plugging in equations is sometimes labeling what my length is, what my width is, and what my height is. So our length here is 7. Our width here is 7. And then our height here is 9. Actually, I think our width would be this one. So, and our length. Actually, I'm so sorry. The length and the width actually don't matter in this case because they're the same length. Normally, the length refers to the longest dimension and the width refers to the shortest dimension. But here, they're the same length, so it doesn't matter which one we label as which. Okay, so let's just plug in the rest. Volume equals 1/3 times length times width. They're both 7, which is really nice, times 9. Okay. Now, sorry, I have to keep zooming in and out. So we have 1/3 times 7, which is 49, times 9, which ends up equally 147 centimeters. And then don't forget your units. So I always like to remind everyone, always put your units at the end. So centimeters cubed because it's being multiplied by 3 dimensions, right? The length, the width, and the height. Those are 3 dimensions. Okay, so our final answer is going to be 147 centimeters cubed. So that's how much like space it's kind of taking up in the world, this pyramid. That's one way you can think about it. All right. Excuse me. So let's move on to what is a cone. Okay, so a cone is a 3-dimensional shape that narrows smoothly from a flat circular base. I'm going to circle the circular, circle the circular base to a point called the vertex. Okay, so a cone is pretty similar to a pyramid, except that pyramids are polygon bases and cones are going to always have a circular base. So the definition is pretty much the same. The only thing that's different is, again, just having the circular base. So it's going to look like this. It's going to have that nice circular base. Um, and then it's going to go up to the vertex point. B for vertex, it's like an upside down vertex. Yeah, so that's what a cone looks like. And here are 2 real life examples. So a traffic cone, you might see these on the street, or maybe when you're walking through a building when they don't really want you to like go in that area, you'll see a traffic cone. So it has that circular base, and then they meet at that nice vertex at that tipping point. Okay. And then hopefully everyone likes ice cream. I certainly do. So we're going to have that circular base. It's a little upside down in this case, but we still have that vertex here. Okay. Yeah. So we have that circular base and then that vertex that's kind of like the tipping, like the tip top point. So that's where two examples of real life cones. And then the formula for cones, again, comes from the same formula that pyramids come from. Volume equals 1/3 base times height. Notice that the formula changes because based on what the base is. So in this case, our base is going to be a circle. So we have to find the formula for what the area of a circle is. So the formula for the area of a circle is volume equals 1/3 pi r squared times height. Okay, and then you can also write it like you don't have to include the parentheses at all. Some people don't want to include the parentheses, and that's okay. That's not always okay, but I think that in this case it's okay. And then you can also put the pi r squared h in the numerator. So yeah, if you like how fractions look more. Okay, so now we have another example to go through. So this is an example for cones. Okay, so now we have that our height, again, we're gonna label our measurements. So I see that our height is 6 meters, and this time, let's actually let's pause and figure out what formula we need to use. So again, we can start off with volume equals 1/3 base times height, then volume equals 1/3. Our base is going to be a circle, so that's why we can use the pi r squared times h. And then now we have the height. Now we need to look for the radius. Okay, so here it says 8 meters, and you might be deceived into thinking to use 8 meters, but actually you need to look at what they're giving you, and that's diameter because it's measuring the entire distance. Radius cuts that in half, so our radius is actually going to be 4. So now let's go back to our formula. 1/3. And then what's 4 times 4? That's 16. So 16 pi times 6. Okay? Now we have volume equals 16 pi times 6 is 96 pi. And then we're going to do 96 pi over 3, which is going to end up being 32 pi. And don't worry about putting like pi into your calculator or anything like that. You can keep it in terms of pi. It's pi is irrational. It could get a little ugly. And then don't forget your meters, your units at the end, meters cubed. Okay. All right. Now that we did a couple examples, I have some for you to try at home. So you can pause the video now. Just let the slide be like this for like 10 seconds. Okay. Now, hopefully you gave these a try, put them on a piece of paper, and then now these are the answers to your two problems. Okay. And then this is a lesson summary, brief summary of what we just learned. The formulas of any pyramid, of square rectangular pyramid, and then volume of a cone. If you have any questions, please feel free to leave it in the comments. I'll try my best to respond. And then please make sure to subscribe to Some by Ms. Venegas. Okay. thank you so much for watching.